design of the structures based on the architectural input, and then you provide the drawings to the site, and based on that the construction will be executed. And then we have general civil. These general civil we have in refineries like hydrocarbon sectors. Their role is like in industrial sectors, the contamination will be more due to the chemical pollution, everything. So all the rainwater, the contaminated rainwater, the oily waters has to be routed through the piping. They are like underground pipings. So we have a separate team which deals with the layout, general layout of the plant, how they are going to provide the water supply for the plant, how they are going to treat the waste from the normal stormwater waste, the oily water waste, or the contaminated rainwater waste. Everything will be planned by general civil engineers, where they don't need to go in depth on structural engineering. Then we have planning engineers at site, whose role is to do the contractual activities, to know the construction phases. And then we have the construction site engineers who do the real execution at the site. And in that construction also we have the quality control engineers. This role is also played by the civil engineers, who just ensure that the product of the quality of the concrete, the quality of the rebars, or everything to the extent as per the design. Then we have a separate team like geotechnical engineers. So the role of geotechnical engineers is to ensure, or is to give the data to the structural engineer, based on which the design will be performed by the structural engineer. And we have another divisions like environment, transportation, PMC. PMC are nothing but they are the client doesn't have expertise on the projects which goes. So what client does, they will hire some civil engineers on behalf of the client. They will control the job. So they were called as project management consultants. So civil engineers has the role to play in all these fields. So students, based on your interest, you can select where you want to be. Like you want to be in site, or you want to go for or you want to go for structural engineering, and you can start preparing from your second, third, or fourth year, so that it will be helpful when you come to the market for job. So now I'm going to concentrate on structural engineering. So structural engineering, like we have lot of scopes. We have bridges, and we have metros. Like nowadays, the metros are like going like everywhere. In Madurai, they are recently planning to put the metro, and metros will be in all the parts of the India. So that has a huge scope. And we in metros we have elevated and underground. So underground, which is based on tunnels and stations. And then we have industrial structures. Industrial structures are nothing but refineries, petrochemicals, and other fields. And residential structures are the buildings, and commercial structures, and railway bridges. And in railways also we have a very huge scope. So now let me come into the field of refinery. See, in oil and gas sector, what we do is we explore the crude oil. Crude oil will get explored from various parts, like various basins, which is below the sea, or oil that is exploration. So exploration will be done, and that will be done through companies like ONGC, Oil India Limited. So these are the few companies which do the exploration. After exploration and identification of the oil, say the oil may be in some deep sea location. So what they do, they put some platforms, they put some offshore platforms in the sea, and that is also done by the civil engineer. We just put the jackets, we put the columns, we take the structure, and we put a temporary platform where the crude gets purified, and through pipeline the crude gets transferred to the tanks or the refinery. So this is the upstream portion, and the downstream portion is the refinery, where we refine the crude. We break the crude. Crude is nothing but a composition of hydrogen and carbon. So what we do, we break the crude in various process columns, and chemical engineers has a major role to play in the field of oil and gas sector, because they design the plant. They say that this is my equipment, it has to be at this elevation. And as civil engineers, we need to provide the support, we need to provide or accommodate the equipments, the piping, and everything which is useful in the production of petrol or diesel or whatever it is, like So the downstream portion is the refinery, petrochemicals, terminals, transportations through which the crude oil is getting broken. And we do metallurgical projects like mining, transportation, and also the smelter plants. And these are all other industrial structures like power plants are there, cement industries are there. So everywhere we have the role. Now you know that typically as a civil engineering student we know, okay, we work with buildings, we know RCC structures, we learn design of beam, design of column, design of foundation. But I just want you to understand what are the technical terms we use inside a refinery. Basically, I'm just concentrating on a refinery so that you get the idea of the structural components or the civil engineering items under a refinery. uh, like there are various structures like pipe rack, process platform, vessel supporting platforms, equipment and static dynamic mission foundations. Don't worry, I will show you the picture of all these. So just I'm giving the names, or I'll just skip this slide also. Okay. Now I will tell. I'm not going to go in depth into the technical or the design. I'm just going to give you a broader view so that you also don't get bored with the things. I will tell you what is happening in the industry and what are the things you can learn to update to the industry standards. So what we generally do is basically we use softwares like StatPro, ETABS for design. The architectural team or the general civil team will prepare the layout, will prepare the initial design, and they will give it to us. And in refineries, there are piping engineers like mechanical engineers, civil engineer, electrical engineer, instrumentation, and architect. We work together. Like it is not we work in different platforms. We work on the same platform, so everyone need a common file. Like we have to visualize the structure which we are going to model. So for that we have a 3D view software. Like we can visualize the whole plant, the whole refinery in 3D. So for that we have the software like PDMS, and this is a very costly software. It is done by Aveva, and now from PDMS we have upgraded to E3D. E3D is also the new software. Now, since we don't have the PDMS machine because it requires a very high configuration, so in order to view, that is in PDMS we create the 3D model, and in order to view the 3D model we use a AutoCAD Autodesk software which we call as Naviswork. Naviswork like Naviswork Manage, Naviswork Freedom. So these kind of softwares we use in which an engineer can view the whole 3D model, which includes the process equipments, the structural elements, the electrical instrumentation cables in their PC, which doesn't require a very high configuration. So now the scope is like we have Tekla modeling. Tekla is also one of the major software which we use because in Tekla, what we do is we do the 3D modeling of the structure and we import it. We import the Tekla file to PDMS. So in PDMS, as civil engineers or structural engineers, we import our structure. Mechanical engineers do the piping. Piping is nothing but the connecting lines through which the fluid or the process liquid flows between two equipments. So that will be modeled by the piping engineer on the same platform, on the same model, or on the same location. So now everything comes on the same platform, like through which the real-time monitoring, any fouling with the structural piping members can be ascertained before going to the site. And this is and finally what we do is we extract. We don't do AutoCAD drawings nowadays. What we do, we extract the AutoCAD drawings from the Tekla model itself. We just ensure that the structures are clash free. There is no any fouling with other piping or electrical instrumentation and other issues. And then we extract the drawing, and the drawing will be converted to AutoCAD and will be installed for construction to the site. So this is the software platform which we are using. Now I just want to give you the basic load flow path, basic things, or the how the as a structural engineer how you should keep thinking. Like see, this is a simple configuration where we have the columns, we have the beams, we have the girders, we have the beams. So this is a particular floor level. In this floor level, we have all the structural components. And generally, why we design the structure? We just ensure whatever load, whatever weight, or whatever mass the building is supposed to carry has to be transferred to the soil. So has to be transferred to the soil. So we design the foundation, we design the structure such that it should be adequate with respect to the strength and with respect to the stability. It should be able to transfer the load to the soil. And the capacity, how much the soil will carry, will be given by the geotech engineers. Like if it is a open foundation is nothing but the foundation without piles. And if we are going for pile foundation, that recommendation also has to come from the geotechnical engineer that these soils are not adequate for the open foundation. We don't get the bearing capacity, so you have to go for pile foundation. So based on the geotechnical recommendation and the technical document given by the geotechnical team, we decide for what type of structures we have to go with pile or with open foundation. And these are some of the site photographs I wish to show you. So this is one technological structure. Now you can see how we have made the steel structure. Mostly in industries we make with steel structures. I will let you know the reason why we prefer steel compared to RCC. And these are all secondary supporting members. These are basically channel sections. And here we go with I sections, or see this is the column with star shape, because in steel you can take or you can create any shapes based on your requirement or based on your design to accommodate the structure. Since a single I section was not adequate, we have made a compounded section or a build up section basically to take the loads of the structure. And in this structure we support all the equipments and platforms. And columns, basically columns are the axial member which takes the axial force and the bending force. So you hope other things like rebar, everything you would have learned in the college, what are the technical components which requires in the RCC column or a steel column. And foundation, see foundation is typically attached to the column, and there are two type of foundation. The top image which is here is the shallow foundation, where you can have an isolated foundation without any pipe, or we have a raft type of foundation. It is like a strip footing basically. And in deep foundation we have piles. Basically there will be piles, and this capacity of the pile will also be mentioned by the geotechnical engineer. So these capacity, everything we get it from the geotechnical engineer, and based on that we will design the number of piles, the spacing, everything will be designed by the structural engineer. So I just want to cover the basic load type and the load flow. Before going to the structural components, I will just explain how we do the design. We generally consider these five loads as the major load, like sustained load and dynamic loads. In sustained loads or static loads, we have the dead load. Dead load is nothing but the empty weight of the structure. See this, the image, these are all tanks. These first image I'm showing, these are tanks. These tanks are basically used in storage. Like after you get a byproduct, after you get the crude, the crudes will be stored in separate vessels, and the petrol, diesel, everything has to be stored, right? After refining the crude, we have to store. So we have the tanks here, and every tanks are kept at a very good distance, so that even if a tank spills, the liquid gets retained within the particular dike area. We never allow the liquid to go beyond that in case of any spillage or any accident. And these industrial structures are prone to fire. So what we have to ensure is our structure is resistant to fire for at least minimum 2 years, 2 hours, sorry. And we ensure that the steel structures are fireproofing, coating of fireproofing has been done, as per OISD standard. OISD 164 is the standard which we use to ensure that a structural steel is resistant to fire. Like in case of any fire, there shouldn't be any major collapse of the equipment or any death. These are the live loads. See, if you see in a floor, the floor in which you are sitting, there will be lot of components. There will be people which we are sitting. There are people like us whom we sit on the floor. We work. So these kind of loads which are resting on the structural components, we call it as live load. And dynamic loads is nothing but moving loads. Like if you see in your home, you will have a motor or a pump which keeps rotating, which keeps the pump starts when you switch on the pump, it starts with zero, and within few seconds the speed of the motor, the rotation per minute, RPM, keeps increasing. So, like we have huge compressors. Compressors are required in the refineries to compress the air, or so that requires a that has a very low RPM. So these kind of low RPM machines where the rotating component ka mass is very heavy. So in that case, the foundations which we design is to ensure that there is no resonance. Resonance in the sense the frequency of the rotating equipment shouldn't match with the natural frequency of the structural component. So these kind of dynamic analysis, when you see in a train or when you see a railway bridge, so there also we ensure the consistent moving, the braking force of the rail doesn't affect the structural components or the bridge of the railway track. And wind load, the major refineries which we do are near the seashore. And seashore are nowadays are prone to more wind. The wind codes has been revised. The IS 875 Part 3 has been revised. And based on that, the wind speed, now they have also add the factor K, KC, KD. So based on that, the due to the higher concentration of wind, wind has to be considered in the design, and this is a part of the dynamic load. And next is the seismic load. Luckily, we Tamil Nadu are in mostly zone 2, but in North India, we are in almost zone 4 and zone 5, which is major prone to earthquakes. So, when we do the design, we have to ensure that our structural doesn't collapse in case if there is any earthquake. For that, also we have to calculate the site spectra. We have to calculate the SABG ratio. We have to find the seismic shear coefficient, and we will be designing a structure for seismic also. These are the, like, suppose in case our base is fixed, you can see the mode shape. Mode shape is nothing but the deflection pattern of a structure. See, when you are as an engineer, you should be able to imagine how the structure will collapse, how the structure is going to fail. So then you will have a idea. Okay, these are the areas which I have to work to ensure my stability of the structure. Nowadays in college, you will be learning a single component like a beam or a column or a foundation. But you should also have a broader view where you're going to use the beam or a column or a structure. How a beam is going to fail, in what will happen in case my base is fixed. In case the base is fixed, you can see how the structure is behaving, and there will be n number of mode shapes. So what the computer designers, the software designers, it will check for all the mode shapes, and it will ensure that our structure is able to safeguard. And in every mode shape, the mass participation also changes. The mass participation is nothing but the weight of the structure which is participating in the dynamic motion of the structure with respect to time. And here is an isolated structure where you can see the deflection is very less. But this is basically based on the roller, and these are some of the forces like which acts vertical on the structure and which acts on the horizontal portion. Like vertical is, we call it as gravity load, and lateral force we call it as earthquake. And as civil engineers, we should be more confident on the stability of the structure. Stability is one of the major issue where we have sliding and overturning. So as per code, we check for sliding and overturning, and we want to ensure that the structure is stable. Many times what happens is architect gives a configuration which is not structurally stable or which can't be done structurally feasible. Then we structural engineers propose a alternate system. Like these are the things which has to be changed or which has to be overturned so that the stability of the structure is not sacrificed. And I just want to show you the load flow path, how the structure behaves. Different structures have different load flow path. Some structures have only one path and some have two or three paths. And one is generally what happens is from the floor, the load flows to the beam, and from the beam, the load flows to the column and to the foundation and then to the soil. You can see here. From here, the loads are getting distributed to the adjacent columns and from here to the foundation. These are the vertical loads, and if we have the lateral loads, that also will be transferred through the column and it will go through the foundation. Now let's see what are the basic forces which comes in the structural element. Like we have tension, we have compression, and we have in tension. What happens is your member tries to fail. You can pull if you hold the string in your hand and you pull it from both the hands. What happens? It gets broken. It gets in the weaker zone. So that is basically a tension failure. These type of things happens in like anchored bolts, structural steel beams, and then we have a compression failure or a bending failure. When you compress a material, a scale, and it tries to buckle, it tries to bend, and up to a point it deflects until the yield, until its elasticity comes to an end, and it turns to plastic stage. After the plastic stage, what happens? Your member gets failed. So bending is also the same, like it is a compressive force, and then we have a torsional component which will be converted to a bending. So now let me show you some images, like what are the various type of structures in refinery. This is one technological structure. So now students, you should be thinking, what is a technological structure? We don't know any technological structures. The name is different. The technological studying is nothing but it is a structure which is used to support the equipments, process equipments. In this, if you can see, there are a lot of equipments. There are heat exchangers, there are vessels, and when this get heat, na, there are air fin coolers at the above. So these are the components which will be done by the mechanical engineers. And this is a real-time site photograph. The same will be visualized in 3D models also. So 3D models are to ensure that these kind of huge structures never fall in the site. We have the staircases, and all these structures has to be designed by civil engineers. These are air fin coolers. If you see here, this is a structural component, and above this there are huge fans. These are very big fans, which is used like in these are process item, and there are below we have the pump. So there are chance of fire. In case of any hydrocarbon leakage, there is a chance of fire. So in order to avoid that, what we do is we ensure that the top slab is RCC slab, which doesn't have any opening, and the structural components are also fireproof. I just told in the starting of the slide, like we have pipe racks. What is pipe rack? Pipe rack is nothing but a RCC structure with steel. We up to certain level we have RCC part, and then we have, if you can see the anchor bolts, and in that we will do the steel erection, and in this we have the pipes, all the pipes which is running on the pipe rack between two equipments. Like yeah, in refineries, what happens is the crude has to be heated at very high temperature, and it will go from one equipment to the another equipment so that the crude gets distilled. So the from one equipment to another equipment, it has to flow through a piping, and this piping grade, everything will be designed by the mechanical engineers, but the supporting system for this piping has to be done by structural engineers. The location, elevation of support required, everything will be provided by the mechanical engineers. See, this is one compressor shed. Like compressors are very huge equipment, and the cost of a compressor is also almost 3 to 4 crores, which can't be kept in open. So we have to make some shed type of arrangement to ensure the compressor are within the confined environment. So we make build-up sections, we make trusses, and we ensure that is covered with sheeting so that the compressors are well within the range. And this is one pump house at raw water treatment plant. Like every refinery requires a very huge quantity of water. The consumption of water is very high. So what happens is we need reservoirs. We need reservoirs to store the water. We need reservoirs to store the raw water. And from that we need to pump the water to the plant. So we build these kind of pump houses where we have a system of pumping, and we identify the plot such that we have this kind of area for water treatment also. And this is a cooling tower. So why we have cooling tower in plants? Because lot of heat will be generated in the process of breaking the crude oil. So while that heat is there, it has to be reduced, because every time the hot water can't be wasted. There is a scarcity of water. So what we do is, whatever the hot water is there, whatever the hot liquids are there, basically water, so that has to cool down and reused back to the refinery. So we have cooling towers where these hot air, the hot liquid, the hot water flows through various pipes, and water keeps flowing from the top bed. So that, and we have exhaust, huge exhaust fan which we have in the kitchen, basically a small size. These fans are which huge, and these structures also has to, these are RCC structures, and we civil engineers do the design of the structures of cooling water tower also. And this will be mostly in all the refineries to ensure the reuse of the water. This is a view of the cooling tower. And we have sleepers, like in railways we use the sleepers for between the rails. Similarly we have sleepers here, and these sleepers are cast here, and these are used to do the pipe support at the low grade, like at the lower elevation. Say a pipe will be running on the floor elevation, for that we use the sleepers. I told you at the beginning there are some underground facilities like General Civil do. So these are some collection pit. These are some collection pits, and these are the pipelines which are used to transmit the contaminated rainwater or the oily water. So this all will be laid before casting the flooring level, so that mm, all the underground facilities beneath the refinery are set in place. Like we have the drainage facility in our homes, the sump, everything. No? So similarly in refineries also we have the underground facilities, and that is also a huge area where you have a better scope. And these are the tank foundations. I just showed you some tanks, and these are all like tanks with dia of say 60 meter, 80 meter, 100 meter. So and these are all built with steel plates, and we have to ensure that the liquid storage is not leaked and it has been properly resting. So you can see the vertical protection. These are all anchor bolts which is used to support the tank column, like sorry, the tanks basically. So these are the nuts and the bolts which will be anchored to the ring beam of the tank foundation. We put a circular ring beam on which the structures get mounted. And these are the equipment foundations. Like equipment foundations are the sense, like we have the pedestal, we have the structural component, we have the anchor bolts here, above which the process column, the vessels will be erected. And behind this you can see a pump. This is a pump here, and this is a block foundation. And in this block foundation we do the dynamic analysis, like we do the rotating and dynamic analysis, and then we ensure the block is adequate to take the load of the pump. And the main objective is there shouldn't be any resonance. The frequency of the pump shouldn't match with the frequency of the foundation. This is the rebar detailing for a pump foundation, and this is the block of, and we keep these kind of openings which will be sealed in the later stage with grouting. I'll show you some pump images. See how you can see how the pumps have been anchored through the bolts, and then we do the grouting at these pockets. Basically, pockets will be left because will come from different vendor. Some will be in India, some will be in abroad or outside India. So what we have to do is we will cast the foundation with the opening. When the equipment arrives at the site, it will be mounted and then the grouting will be done to arrest the movement of the pumps. These are some heavy cranes. See the cranes which has a capacity of even 2000 metric ton. The equipment which comes in a refinery has almost a weight of say 400 ton, 500 ton, 600 ton. So there are heavy equipments, and while lifting and erection of equipment, you can see I have just shown you some photos of lifting of a column. So this requires that the height is like 70-meter, 80-meter, 90-meter columns which has to be lifted and erected. For that, we need a higher capacity of crane, and this kind of works has to be done with utmost safety precautions. This is the compressor foundation, which is within the compressor shed. These are pipe bridges. Pipe bridges are nothing but when we have a road, we have to give the sorry we have to give a clear height for vehicle movement. So what we do is we create bridges of like 20-meter, 30-meter. So can you imagine how can you put a structural beam or structural steel beam for a length of 20 or 30-meter? We go for trusses. We go for build-up section. We go for trusses for the span of 20-meter, 30-meter, so that the routing or the piping or other equipments or services which has to be routed can be routed and supported. This is a typical pipe rack. The same concept which we do for bridges. Like this is a viaduct portion and this is the bridge portion. Similarly, a frame and with the load, the same we do for pipe racks and structures and industry. And now you can ask why we have to go for steel structures. Why not we do everything with RCC? So the use of steel structures is like the construction time will be very less because what we do is we order, we do the design, and we give the drawings to the fabricator. The fabricator design the connections using Tekla, and they send us for our review. We have our standards. Based on that, they will design the connections, they will design the fabrication drawings, and send us for our review. We will review the fabrication drawings and give the go ahead, and after that, it will be fabricated. Nowadays, we have modular construction. Modular construction in the sense like the piping, the structure, the equipment, everything come as a module. The only thing at site is to bring the module and do the erection at the site. No need of separate components. Like before we do is we bring the structural components, then we bring the piping, then we bring the equipment, and erection will be at the site. Nowadays, a single component will come, the whole module will be erected at the site. So these kind of speed can be achieved only with the steel structures. And steel makes large span and base size possible, providing more flexibility for the owners. And steel is easier to modify and reinforce if architectural cases are made to facilitate. Like, say, if a plant is like almost 30, 40 years, the client wants to add some extra facility. Like now, BS6 is there. BS6 petrol ke liye, we have made a lot of changes in the existing plants also. We have done the revamp. Revamp is nothing but modifying the existing plant. So for that, what the client wants, they want to add a new equipment to reduce the pollution or to refine further the product. So in that case, we have to use the existing structure. So if it is a RCC, then the remodification is different. But in case of a structural steel or a steel structure, we can easily modify the members to take the additional load of the extra equipments or the additional loads which are coming. Steel is lightweight and can reduce foundation cost. And then the steels are durable. And let me show you the connections, the braced frames and the rigid frames which we have. These are some of the connections we have. Like without bracings also we'll provide. Generally we provide bracing in one direction where we have the minor axis of the column, and in major axis we go for moment connection. I'm showing you typical connections details which we follow at the site. Simple moment connections, everything I have shown you. Left side is a simple connection where the web portion alone is connected. You can see there is no connection made with the flange portion. And in case of a moment or rigid connection, where we never allow the rotation. Simple connection is where we allow the rotation, and in rigid connection, we never allow the rotation. Like the top and bottom flange plates are getting arrested with the top and bottom plate, and these are all bolted. And here there is a fixed connection, and in both the directions, we have given a rigid connection. Generally, in major axis, we give a rigid connection, and in minor axis, we go for bracing system to ensure that the load flow is being transferred to the foundation. These are fully restrained connections where the slope or the deflection at the point is zero. And here we have partial restraint connections. So basically what I am to say is like in industries also we civil engineers have a major role to play because structural and mechanical engineers are the key building. Like at the starting you told that the best creators are civil engineers. So we have more scope in this area, like in the industry, refinery, petrochemicals area also with us, and other than the buildings. So the summary of this is identify the force and actions to be reduced on the structure. You have to design the path, the load path, and you have to economize your design. And we have the reviews like at 30% stage, at the 60% stage, client reviews our 3D model, and they provide their comments like based on because they are the people who do the doing the operation. They want like these levels. We want this much support. We want platforms here. We want easy access here. Everything we modify based on the client requirement at the intermediate stages like 30, 60, and 90% of the project, so that at the last client should be satisfied with the outcome of the product at the end. So client will be continuously monitoring the projects. So I've just given you some brief idea, and in case if you have any query, now you can ask me. All the best.
Hello, sir. Yes, sir. Hello.
We also use the basic components like StatPro and ETAP softwares, which we do. And process related, we have follow the process industry practices. So the only thing is you have to start exploring the organizations or the company which works in this sector, and you can apply after your UG. There is no special courses or specific things which has been required for this.
Okay, sir. Thank you, sir.
Dear students, any doubts? Others, if you have any doubts, kindly ask.
Student,
முடிஞ்சதுங்களா sir? Imran sir, shall I conclude, sir?
Sure, sure, sir. Sure.
Okay, okay. MOC team.
Yes, sir. Yes, sir. Ready, sir.
Uh,
I would like to call upon Ms. Sweta from Department of Civil Engineering to give the thanking you address.
Warm greetings to one and all present here. First, a special thanks to our TMHNU management for giving the consent to organize this webinar. On behalf of us in Industry, Institute and Partnership Cell and Department of Civil Engineering, I'm humbled and honored to have the privilege of delivering the vote of thanks. Now, I would like to thank our Honorable Secretaries, Mr. A. Rajkumar Sir and Mr. A. S. R. Maheshwaran Sir, and Joint Secretary, Mr. S. Naveen Sir, for their overwhelming support for conducting this webinar. Thank you, sir. I would like to thank our respected principal, Dr. C. Madalai Sundaram Sir, because of whom this webinar was possible. Thank you, sir. Next, I would like to thank our Vice Principal, Mr. N. Madhavan sir, for his magnificent effort for the smooth conduct of this webinar. Thank you, sir. I would like to thank the Placement Officer, Dr. C. Karthikeyan sir, for his cooperation in conducting this event. A special thanks to our chief guest, Mr. G. Emmanuel Fernandez. We are deeply grateful for your presence and the valuable insight you shared with us. Your time and energy are greatly appreciated. Thank you, sir. My sincere thanks goes to our head of the department, Dr. E. Anandakrishnan, sir, for his unwearying support in making this webinar a great success. Thank you, sir. I'm very happy to express my vote of thanks to our event coordinators, Dr. C. Sivakandan, sir, and Mrs. B. Soumya, ma'am, for their phenomenal effort which made this webinar a great success. I would like to thank all heads of various departments, teaching and non-teaching faculty members for their excellent contribution. Last but not least, I would like to thank all the students, internal and external participants for their good support and cooperation. Thank you all.
Thank you. You can conclude. Okay, students, thank you for your valuable contribution. And also, thank you, sir.
Thank you,
Emmanuel,
sir.
sir.
Thank you for giving this opportunity, and I
Okay.
wish all the students all the best in their future endeavors.
Okay, sir. Thank you, sir. Thank you.